All right, so because we are not going to have time to go over this in class before our Unit 3 test, I'm going to go ahead and record this now so that if you want to review this at home, you can watch this to kind of figure out what's going on with this worksheet number 24, all right? So we got 6 different relationships here. We're either going to be given our slope and y-intercept, or we're going to be given our equation. We could also be given the graph of our line, and then we're going to have to determine whether it's proportional or non-proportional. So basically, each of these boxes needs to be completely filled out, and in each one you only get one little piece of information. Luckily for us, we can fill out every single missing piece of information with only what we're given. So let's start with number 1. Here we're given a linear equation, y equals 3x minus 5. So we know that our linear equation formula is y equals mx plus b, where m is our slope and b is our y-intercept. So whatever number we see in front of x in our equation, that's our slope, and whatever number we see added on to the end of our equation, that's our y-intercept. So we look down at our equation and we see y equals mx plus b. That's in the form that we want. So we look for m. It's right in front of x. 3 is right in front of x there. So we know that our slope is 3. Now because when we get, actually never mind. I'll hold off for a second. Now we look for the number hanging off on the end. We see that it's minus 5, and in our formula we have plus b. So we know that our b value is not at positive 5, our b value is actually at negative 5. So for our y-intercept we'll say it is 0 comma negative 5. Y-intercept is wherever our x coordinate is 0. Alright, let's go ahead and graph this now. The very first step when we're graphing something like this, a linear equation, is plot the y-intercept. We have a point here, we have coordinates 0 comma negative 5. We're going to put that right down there on negative 5. We start at the origin, we'll go down 1, 2, 3, 4, 5, and make our first dot right there at 0 comma negative 5. Now once we have that first dot made, we need to figure out where our second dot is going to go. And to figure out where exactly that second dot needs to be, we're going to use our slope, right? And we're going to do rise over run. So 3 is going to be our rise, but we don't have a denominator to figure out what our run is going to be, do we? Luckily for us, we can just put 3 over 1, giving us a run of 3. Now if we have a slope that's already in a fraction, like we'll see here in number 2, we're just going to rise the number of units in the numerator and run the number of units in the denominator. So we're going to rise 3 and run 1 from this point right here. We're not going back to the origin. We're going from this point right here. We'll go up 1, 2, 3, and we're going to go over 1 and make our dot. So don't make a dot after going up 3. Wait until you've done both movements before you draw your second dot. Then you get your ruler out, you connect those 2 dots together. And we've got our line. We see that from left to right our line is sloping uphill, which means we need to have a positive slope, and we did. So we know that's good. Now all that remains is for us to ask the question, is this proportional or not? Well, the 2 conditions that every relationship needs to satisfy in order to be called a proportional relationship is it needs to be a straight line that goes through the origin. So here we have a straight line, but it doesn't go through that origin there, so we know that it is non-proportional. Okay, and any proportional relationship we have must go through the origin. That's what makes it proportional. And if this line went through the origin, we would have a y-intercept at 0, 0, right? It's that point right there on the y-axis, right there, the origin is at 0, 0. So if we see anything else for our y-intercept, we know right away that our equation is non-proportional. Like in number 2, we see our y-intercept is at 0, 2. Right away, that tells us this is going to be non-proportional. So, in number 2, a little bit different. Let me take a step back here because we're not starting with an equation, we're starting with the slope and the y-intercept, and we have to write ourselves an equation. Luckily for us, we're just doing the reverse of what we did in number 1. So instead of pulling those numbers out of the equation and identifying them, we're going to take these identified numbers and plug them into the equation at m and at b. So y equals blank x plus b. Our m represents slope, and that's 2 over 5. Plug that in right in front of the x. And our y-intercept, represented by b, is positive 2. So we'll add plus 2 onto the end of our equation. Just like that. Now we got a graph. This equation looks good. It's in the right form. We make our first dot at 0, 2. Start at the origin. We're going up positive 2 spaces and drawing a dot. That right there is our y-intercept, our starting point. Now we're going to rise 2 units and then run 5 units. So let's rise 1, 2. And let's run over 1, 2, 3, 4, 5 and make our second dot right there. Connect those 2 points with a line, and you've got your graph. Again, from left to right, we're going uphill, giving us that positive slope that we want. Now, number 3, we don't have any numbers to start with at all. The only thing we have to work off of is this graph. Again, all of these ideas are connected, so we can use what we learned in the previous 2 problems right here, right? We plotted those y-intercepts right there on the y-axis at the number that they told us to. Now we're going to find where that point is on the y-axis right there, and we have to determine what the coordinates are of that point. If we start at the origin, we're going up 1, 2, 3, 4. So that point right there is at 0, 4 for our y-intercept. All right? Now we're going to start on our leftmost point, and we're going to use rise over run to find our slope. So we're going to rise downward to get to this second point over here. We're going to go downward 1, 2, 3, 4, 5, 6. And then we're going to go over 1, 2, 3, 4. So we went down 6 and right 4. That's going to give us a slope of 6 over 4, which is equal to 3 over 2. However, because we rose downward, it's really like going -6 units. -6 units, which gives us a slope of -3 over 2. And I'll box it up just so you don't get confused with this. Our slope here is going to be -3 over 2. Another way you could do that is, without adding on that negative there, is just looking at this line, right? If you drew a little person on the top left of the line and told them to walk to the other side, they'd be going downhill, which means that we have a negative slope. Now we need our equation. Again, just like in number 2, plug in your slope, plug in your y-intercept. Y equals -3 over 2 x plus 4. Don't forget about x in there, Got to make sure you have that to make our equation correct. And again, we have to ask ourselves, does this line go through the origin? It clearly does not. This is non-proportional. All right. Moving on down to number 4. Now that we've got kind of the gears turning here, let's go ahead and go through these. So number 4, we're starting with a slope. We're starting with a y-intercept. And our y-intercept here, hey, look at that, is at 0, 0. We'll mark that down. And we know immediately that our relationship is proportional because it crosses through the origin. Now let's just confirm that it's in fact linear, because we kind of assumed it would be linear and called it proportional, but we know that it's going to be linear. We're going to go down 5 and over 1. Rise over run. We're going to go down 5 because it's a negative 5. So we're going to go down, and then we're going to go to the right 1 unit. Connect our line, just like that. And we can see that with our negative 5 as a slope, our line is now going downhill from left to right. So let's go ahead and write this equation. We're going to plug in negative 5 for m, y equals negative 5x, and then our b value here is 0. So we don't need to add plus 0 onto the end. We can just leave it exactly like that. Y equals negative 5x. If you randomly hear this for whatever reason, if you can bring in a box of tissues to class, I will give you 10 rich tickets. All right? 10 rich tickets if you can donate so graciously a box of Kleenex to class. I know no one's probably going to hear this because I don't know if people actually watch these videos or not, but if you do hear this, this is your opportunity. All right, anyway, let's go to number 5 here. So our y-intercept we see is right here at positive 2. We'll call that 0, 2. That's the coordinates of that point. We see that we're going to rise downward 1, 2, 3, 4, 5, 6. Right, negative 6 because we're going down. And then we went to the left 1. So because we went to the left and because we went down, now I'm confused because wait, we've got a negative and a negative. I don't know what I did wrong. So what I did wrong there, and hopefully some of you caught my mistake, is that I started with the rightmost point because it's above the leftmost point. But we always want to start with the leftmost point because then we can see we'll go up 1, 2, 3, 4, 5, 6, and we'll go over to the right 1. And you may realize that negative 6 over negative 1 is the same as 6 over 1, which is just 6. So going up and to the right, those are both positive movements. And going down and to the left, those are both negative movements. So we'll stick negative signs on that number of units, 6 and 1, because we went in negative directions. Doesn't matter though, because a negative over a negative would give us a positive anyway. And just to confirm, we can look from left to right. That line is definitely sloping upward. Let's plug in m and b, and now we've got our equation written out. Does not go through the origin, so it is non-proportional. And now to number 6, we're starting with the equation. We can see our m is negative 6 over 5, and our b is positive 2. So we'll go up to positive 2 on the y-axis. Now we're going to go down 6, but to the right 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Second dot. right there. Get your ruler, connect it up. It's a beautiful looking line right there. From left to right, we're sloping downhill. So we know that our negative slope there is correct, and we graphed that correctly, but it doesn't go through the origin again, so this is non-proportional. Hopefully that was helpful. If you took the time to watch this video, I appreciate that for, doing the extra work you need to get yourself ready for this test. If you have any further questions, you can ask me in class before the test. I know it's kind of short notice, but I appreciate it and happy studying.